Hello everybody, this is Mr. Combs and we are in the last week of classes before finals. Next week you will review and take your final exam. So let's wrap up this unit on factoring by first of all talking about factoring completely. Factoring completely. So when we factor completely, all that means is that after we factor a polynomial, we need to check the resulting factors to make sure that those can't be factored further. So we've done this all along. The first thing we'll do is we will factor out common factors, and then we'll factor again. But you may have to use more than one step on the factoring list to factor completely. And let's just do a couple of those examples so that you can see how you might go about working through those. Before we do that, let's talk about the factoring list a little bit and review the steps that we might take to factoring. So if I'm going to factor, the first thing I'm going to do for all polynomials for my y there, alright, is I'm going to factor out the GCF. So that's what I do for all polynomials. After I factor out the GCF, or if the GCF if there is no GCF, so there's no greatest common factor, then what I want to do is I want to look at my polynomial and I want to say, do I have 4 terms? If I have 4 terms, then I'm going to factor by grouping. If I don't have 4 terms, I'm going to ask myself, do I have a trinomial? If I do have a trinomial, I'm going to ask myself, is it of the form x squared plus ax plus b, where there's no number in front of x squared? If that's true, then I'm going to write x and x in parentheses, and I'm going to fill in the blanks. Okay? If that's not the case, if I have a trinomial that is of the form ax squared plus bx plus c, where I do have a number in front of x squared, then what I'm going to do there is I'm going to use trial and error but I have the z-box that's going to help me organize my thoughts. If I don't have a trinomial, I'm going to ask myself, do I have a binomial? If I have a binomial, I'm going to check to see if it's a difference of squares. And if it is, then I'm going to use the formula a squared minus b squared is equal to a plus b times a minus b. Basically what I'm going to do there is I'm going to take the square root of both of my terms, put a plus between those square roots and a minus between them. So this is the sort of the idea of factoring completely. You may have to go through more than one step for a certain polynomial based on the resulting factors. So let's look at just a couple. We'll look at about 3. of these in this video. So let's look at this one. What if I have v to the third minus 64v squared minus 4v plus 256? And the directions are to factor. You're asked to factor this. We want to be able to factor this completely. Okay. So the first thing I'm going to do is I'm going to look for a common factor. I have v cubed minus 64v squared minus 4v plus 256. There's no common factor that's common to all four of those terms. So I have to skip step 1. But I can use step 2 because I need to factor by grouping here because I have 4 terms. So what I'm going to do is I'm going to group the first 2 terms together and the last 2 terms together, and I'm going to factor out common factors in each group. So in the first group, I notice that I have a v that's in both, and I can take out the smallest exponent. The smallest exponent I have is squared, so I can take out a v squared. When I do that, I'm going to have v minus 64 left over. Now, here I notice that 4 and 256 both have a factor of 4 in them, but since I want the v to be positive and the 64 negative, and I have just the opposite here and here, I'm going to take out a negative 4. So when I take out a negative 4, I'm going to be left with a positive v, because negative 4 divided by negative 4 is 1, and a minus, because a negative and a negative will make that be a positive, 64, because 256 divided by 4 is 64. Now the expression that's in parentheses is the same, so I'm going to factor that out, and then I'm going to write what's left after I get rid of v minus 64. What do I have left? I have v squared minus 4. So v minus 64, that's pretty much not factorable. But when I look at v squared minus 4, I notice that I have a binomial. So I have a binomial. I'm going to see if that binomial is a difference of squares. I know the first one's not a difference of squares because v is not a perfect square. But v squared is a perfect square, and so is 4. So I can factor this as a difference of squares. And that's what I mean by factoring completely. You have to, after you factor, check each of your factors to make sure that they can't be broken down further. So that's what we mean by factoring completely. So let's look at v squared minus 4. What do I have to square to get v squared? Well, just v. And what do I have to square to get 4? That's 2. So I can factor v squared minus 4 as v plus 2 and v minus 2. And if I bring down v minus 64, this is basically the factored form, the completely factored form. What do you think? Not so bad. Alright, let's take a look at another one. Let's take a look at b cubed plus 12b squared plus 36b. When I look at this, I notice that I have a common factor of b. All 3 of these have a b in them, and the lowest b I have is b to the first. So I can take out a b. So when I do that, I'm going to have b squared plus 12b plus 36. Now, I can't forget to look at that b squared plus 12b plus 36 to make sure it can't be factored. It's a trinomial, it's of the form x squared plus ax plus b. There's no number other than 1 in front of b squared, so I can factor this by writing b and b in parentheses and filling in the blanks. I need two numbers that when I multiply them together, I get 36, but when I add them together, I get 12. So when I multiply these two numbers, I should get 36, but when I add the two numbers, I should get 12. Well, let's see. What times what is 36? 6 times 6 is 36, right? Nine times 3 is 36. I'm sorry, not 9 times 3, that's 27. Let me erase here. 9 times 3 is 27. What do I mean? Yeah, 9 times 4. So 9 times 4 is 36. 3 times 12 is 36. Right? 1 times 36 is 36. And then, of course, I have the negatives of these as well. Negative 6 times negative 6 is 36. Negative 9 times negative 4. Negative 3 times negative 12. Negative 1 times negative 36. All those are 36. There may be others, but this is good enough for us to start with. Actually, yeah, there's 2 times something is 36. But anyway, this is good enough for us to start with. All right, what's 6 plus 6? 12. We got it right off the bat. 6 plus 6. So that means this is going to be b plus 6 and b plus 6, because it's a positive 6 and a positive 6. We can't forget our b here on the outside, so this happens to be the full factored form. And there's one other thing we could do. We could write this like the cool kids and write this as b plus 6 squared. So b times b plus 6 squared. If we wanted to, either one of these is totally okay. Okay, let's look at this last one. What if I have 10a to the 5th plus 25a to the 4th minus 15a to the 3rd? All right, let's try this. The first thing I need to do is look for common factors. I notice that I have a's in each, and the lowest number of a's I have is a to the 3rd, so I can take a to the 3rd out. And then 10, 25, and 15 are all divisible by a factor of 5, right? So I can take 5a cubed out. So when I do that, I'm going to get 2, because 10 divided by 5 is 2. So 2a squared. I had 5a's. I took 3 out. Plus 5. 25 divided by 5 is 5a. I had 4a's. I took 3 out, so I'm left with 1. And 15 divided by 5 is 3. And I had 3a's, but I took them all out, so I'm left with none. And let's bring the end of those parentheses closer here. So now what I need to do is I need to check to see my expression inside parentheses. I need to check to look to see if that's factorable. Well, this is going to be z-boxing because I've got a trinomial and I have a number in front of a squared. So I'm going to try the z-box here. So 2a squared and negative 3 on top and 5a on the bottom. So 2a squared, I can break that up into 2a and a basically. And 3 I can break up into negative 3, or negative 3 I can break up into negative 3 and 1. 2a times negative 3 is negative 6a, and a times 1 is 1a. If I add these two things together, that's going to give me a negative 5, but I need a positive 5. So what I can do is I can get rid of this negative from the 3, and I can actually put the negative on the 1. So I'm going to have negative 1 times 3. That's still going to give me negative 3. And then what that is going to do is it's going to take this negative away from the 6, and I can put it on the 1. So I'm going to have 6 minus 1, and that's 5. So that means 2a minus 1 and a plus 3 are my two binomials. So 2a minus 1 and a plus 3 are the two binomials. I can't forget about my buddy 5a cubed. So 5a cubed goes there, and this is the complete full factored form. I've factored completely because 2a minus 1 and a plus 3, they're binomials, but they're not differences of squares. Alright, so I hope this helps you think about factoring completely.